This is a demonstration of a simple use case example connecting a emulated car through the High Mobility API to the IOTA Tangle. We are using a private masked authenticated messaging stream to achieve this. So let's get started. Before we can do anything, we will need a couple of things. First, we need this example's source code. We can clone this from GitHub. This is linked below the video. Next, we need a shell session with a recent version of Node.js installed. And we need a high mobility account. You can create one for free on high-mobility.com. Once you've done this, you will end up in a dashboard looking like this. And here we can get started creating our first application for this demonstration. We'll click the plus right here and we'll choose Cloud App. We will call it MAM. Okay, next up we need a emulated car because we are trying to fetch location data of this car. So yeah, we need a car first in order to receive location data. We'll go back through our dashboard. We click on Porsche. We click emulators, we click plus, and we will create a new Porsche Cayenne emulator. We will simply call it car. There we have it. We will link it to our application. We'll click back to our application and there we have it. We have our application with a emulator attached to it. And that's all we really need to set up right now on the High Mobility dashboard. Next up, we need to modify our source code to link this application and simulator through our application. We will need a client certificate for this, so we'll click on the client certificate tab, and here we have a little piece of code which we'll need in a moment. So I will just go ahead and copy this right now without the import, and I will open up my source code. This is the source code I cloned from GitHub. I already entered the MAM example folder, and we will open up the sender JavaScript file right now to change our variables. As you can see right here on line 25, I have a fix me. This is our placeholder for our high mobility client certificate. All I need to do right now is paste it right here. And we can remove this placeholder and we can remove the fix me as well. Okay, now we have our client certificate installed. Pretty simple. Next, we need the access token for our emulator. We can get this by going back to our dashboard, clicking the triple dot right here, and clicking on access token. Here we can see our access token for this emulator. We can simply copy it, go back to our source code, and replace the 3 dots near access token right here. Oops. There we go. We can remove this fix me line as well. And this is all we need to do right now to get our example up and running. If you want, you can modify some other variables as well, like, for example, the IOTA node it's connecting to. Currently, we're using the devnet. You can also use the type of MAM stream we're using, shared secret if you're using it, a restricted mode. Please keep in mind that if you change these two, you will need to change it as well in the receiver JavaScript file, since it's a shared secret. But we'll keep it at the defaults for now. We will close up this file. And we need to do one last thing before we can start running our application. And that's launching our emulator, because the emulator only sends out coordinates if it's running. So let's go back to our high mobility dashboard right here. We will click on the image of the car, click launch emulator. There we have this neat little 3D model with the current state of all components on it on the side as well. So we can see our vehicle location right here. We will go back to our emulator in a moment, but since we have it running now, we should be able to get our application up and running. To do this, we will first need to make sure we have all our dependencies installed. So I'll run npm install. This will fetch our dependencies, install them. This will only take a couple of seconds. And now we can run our sender. We can do this by typing in npm run sender. And what this does is this fetches the location of our emulated car from high mobility. And it posts these coordinates through our MAM stream on the Tangle. We will get a command right here, which we can use to listen in to our MAM stream. This piece of code can be run on any other system you like. It doesn't have to be on the same server or computer or network or physical location. As long as it has access to the same IOTA network, it should be able to receive these messages. So let's go ahead and run our receiver in a new tab. There we go. As you can see, it already received its first coordinate. But it won't change right now because our sender only sends coordinates if the coordinates changes. So let's simulate a ride. We'll go back to our emulator. We click the little run icon here. We'll click on slow driving, and this will actually simulate a car ride. We'll click the play button. You can see there's a little map right here. You can see that our car is actually moving right now. On the left-hand side in the logs, you can see that our location is being updated, that our speed is being updated. If we go back to our sender, you can actually see that it has sent out some new coordinates right now. Those differ from the first low coordinates. And in our receiver, the updated coordinates should pop up at any moment now. This is all propagating through the IOTA Tangle, so it takes a couple of seconds before our receiver actually gets our location. But there it is. This will continue to run as long as you'd like. And it's a safe, secure, tamper-proof way of sending location data utilizing the IOTA Tangle and the High Mobility API.